So in this video, we are going to discuss representation of organic compounds. There are three different methods to represent the given organic compound. In that, the first one is complete structural formula. Second one is condensed formula. And the third one is bond line representation, bond line notation of a organic compound. In this, the first one is complete structural formula. In this complete structural formula, we write the symbol of every element, and also we indicate every bond, whether it is a single bond, double bond, triple bond, whether it is a CH bond, CO bond, NH bond, whatever it may be. If these two are followed, then it is called complete structural formula. For example, you can see this is ethane molecule, and this complete structural formula says between two carbon atoms there is a single bond, and here totally 6 hydrogen atoms are present, each carbon with 3 hydrogens. And ethene, so here every element symbol is indicated, every bond is also represented. So that is a complete structural formula. You can take acetylene, that is ethyne molecule, and here that is methyl alcohol. But in this, whenever there is a heteroatom and that heteroatom contains lone pair, those lone pairs may or may not be indicated. But here both are correct, and this is about a complete structural formula. And the second type of representation is a condensed formula. In this condensed formula, symbols of every elements are indicated, no doubt about it. But most importantly, single bonds are not indicated. Single bonds. But here we indicate CC double bond and CC triple bond. But CC single bonds are not indicated, CH single bonds are not indicated, any single bond is not indicated. And if you see, this is ethane complete structural formula. When it is condensed, you will be indicating ethane like this, CH3, CH3. So these single bonds are not represented. This single bond is also not represented. By seeing this, you need to understand that this carbon has 3 hydrogens, this carbon has 3 hydrogens. This is ethene molecule, so these single bonds are not represented, but CC double bond must be indicated like this. And acetylene molecule, you can take acetylene, here also the symbols are indicated, but single bonds are not indicated. A triple bond is indicated, CC triple bond. And this is methyl alcohol in bond line in condensed formula, methyl alcohol in condensed formula. This is the representation. So this is about a condensed formula, and here you can see this is the particular example. So in this 1 2 3 4 5 6 7 8 carbons you have. Terminal carbons are with 3 hydrogens, and the other carbons, internal carbons, they are with 2 hydrogens each. So this is the correct representation. It can be further condensed to this. So here we have CH2 groups. There is repetition of 6 CH2 groups. So you can represent simply like this. So this is about condensed formula. And the next one is bond line notation. The carbon atoms in straight chain should be drawn in a zigzag format. You can see 1 2 3 4 carbon atoms, and here 1 2 3 4 carbon atoms. The pattern is a zigzag, so the carbon framework is indicated like this. So here we don't write the symbols of carbons, we don't write the symbols of hydrogens, we write only the symbols of heteroatoms, hydrogens attached to heteroatoms. And the next one, When you are drawing double bond, you have to see that there should be maximum angle of separation. So here there is a double bond like this, and we have to maintain maximum angle of separation that is nearer to 120. It's not exactly 120, nearer to 120. This is sp2 hybridization, sp2. So this is the correct representation, but this is the wrong representation. So maximum angle of separation we have to maintain. So this is the wrong representation, this is the correct representation. Next, when single bonds are drawn, need not to worry about the direction. When drawing single bonds, the direction in which the bonds are drawn is irrelevant. So here you can see this carbon, here this carbon, you write in this direction or in this direction, both are actually same. So it doesn't mean you have to write only like this. So here, in fact, this one and this one, these are same. So this is correct, this is also correct. And the next one, in case of heteroatoms means other than carbon and hydrogen, other than carbon and hydrogen. So all heteroatoms symbols must be indicated, point number one. And hydrogens attached to heteroatoms must be indicated. See, for example, here in this example, 1, 2, 3, 4 carbon atoms are present. So, like this, 4 carbon atoms. So, 1, 2, 3, 4, 4 carbon atoms. From left side, at a second position, there is OH. So, there is OH. And already I told you, hydrogens attached to heteroatom must be indicated. So here this is the correct bond line notation, and even if bond line notation is given, we can understand this structure, and very clear this is indicating one carbon atom. Carbon always shows tetravalence. Here one bond is indicated means remaining three are definitely hydrogens. Here if you take this particular carbon, one, two, three bonds we have, so another must be hydrogen. And if you observe this third carbon, here we have indicated two bonds and the remaining two will be hydrogens. So all heteroatoms other than carbon and hydrogen must be drawn, and any hydrogen atom attached to heteroatom must be indicated with the symbol. And the last point, the very important, the maximum valence of a carbon is 4, and of course you should not write more than 4 bonds. So carbon has only 4 orbitals in its outermost shell. So carbon shows only tetravalence. For example, let us convert this complete structural formula into bond line notation. In this we have 1, 2, 3, 4, 5 carbon atoms. So here 1, 2, 3, 4, 5 carbon atoms. At the second place you can see there is a branch. So here that is branch with one carbon atom. And here we have here one branch, two branches. So here like this. So hydrogen, there are no heteroatoms, and we have to understand that this is carbon, only one bond is drawn means remaining three are hydrogens. And even let us convert this. Here we have, so like this, one, two, three carbon atoms. First let me draw three carbon atoms and a double bond with a maximum angle of separation. And it is not actually terminal carbon at this position. Here we have one branch, here we have one branch. So here like this, and hydrogens should not be indicated. Hydrogens attached to carbons are not indicated. So this is about bond line structure, bond line notation. So 1, 2, 3, 4, 5 carbons, 1, 2, 3, 4, 5 carbons. Next here we have 1, 2, 3 carbon atoms. So 3 carbon atoms, and every carbon has one OH group. So here we have OH group, here we have OH group, here also we have OH group. Lone pairs may or may not be indicated. So this is about representation of organic compounds. And one more important concept, that is three-dimensional representation of organic compound. In this three-dimensional representation, we have a wedge-dash formula. According to this wedge-dash formula, every sp3 carbon, the four groups of sp3 carbon, so two are drawn by using normal line, one is by using solid wedge, another one is by using dashed wedge. So we use three types of bonds here. So here this is one type of bond, this is a second type of bond, and this is a third type of bond. So here the groups which are attached to normal line, that is lying on paper plane, this is above the plane and this is below the plane. So in this, these three atoms are in the same plane, one plane. Of course, this is above the plane and this is below the plane. That is the representation. Even if you see this particular example, so hydrogen and bromine are in the same plane. Ethyl group is above the plane, methyl group is below the plane. Even if you observe this particular example, so this vinyl group and ethyl group in the same plane. So hydrogen is above the plane and methyl group is below the plane.